Hey guys, okay, here is our recording for, again, still 4.2, okay, increase function and decreasing function. So let f be a function defined on an interval. Let's call this interval I. And let x subscript 1 and x subscript 2 be any 2 points in interval I. Okay? F increases on interval I if x subscript 1 is less than x subscript 2. That means in the result, as a result, f of x subscript 1 is less than f of x subscript 2. Okay? And f decreases on I if x subscript 1 is less than x subscript 2, but f of x subscript 1 it's greater than f of subscript 2. Okay? So what that means is x1 always go before x2. That's all that is, okay? So I'm picking 2 points, x1 and x2. x1 is always less than x2. No big deal on either one, okay? But it increases if the y value of x1 is less than the y value of x2. So what does that mean? That means I'm going from small to big, so that has to be increases. It decreases if the y value of x1 is greater than the y value of x2, and that makes sense because I'm going from high to low. Okay, so let me give you some extra information here. Functions with positive derivatives are increasing. Okay, and so now we will use derivative to say that it's increase or decrease, which is a lot easier than before. Okay, functions with negative derivatives are decreasing. Okay. All right. Corollary. Increasing and decreasing function. All right. Let f be a continuous function on closed interval a to b and differentiable on open interval a to b. Okay, if f prime is greater than 0, which is positive, at each point of open interval a to b, then f increases on a to b. Okay, if f prime is less than 0, which is negative, at each point of open interval a to b, then f decreases on a to b, okay? So in plain English, what this is saying is that positive derivatives is an increasing function. Negative derivatives is a decreasing function, okay? And let's put that to use for example 4. Example 4, for each of the following, use analytic methods to find A, the local extrema, it's back, B, the intervals on which the function is increasing, and C, the intervals on which the function is decreasing, okay? So first I need to find the derivative anytime I'm asked to find the local extrema. So let's do the derivative. G prime is 2x minus 1. Set it equals to 0. X is going to come out to be a half. Okay. I have no endpoints, so this is the only thing I am going to use. But when I have 1 point, it's kind of hard for me to see if it's minimum or maximum. So make sure I use like a negative 100 or positive 100. Okay. So f of 1/2 is 1/2 square minus 1/2 minus 12. So with some basic math going, let's see if I can do the basic math. That's 1/4 minus 1/2. I'm pretty sure at some point I'm going to need to convert that to denominator 4. So that's going to be 48. And that into a 4. So that's going to be a 2. So that is going to be 1/2 minus 2/4. That's going to be negative 1/4 minus 48 over 4 is negative 49 over 4. Okay. Well, I kind of don't know if that's minimum maximum. So let's do some far out points. Negative 100 squared is positive. F of a positive 100 is still positive. So I have 2 positive points, and this is negative somewhere in the bottom. So this is definitely a minimum. Okay. So minimum, would you agree with that? Perfect. Min is what? Negative 48 over 4 at what? X equals to a half. Gorgeous. Okay. Let's do B. What did B want us to do? The interval. Find the intervals on which the function is increasing. Now, this is the new theorem that we just studied. Okay. So I'm still going to use that half. But I'm no longer using f of x. I'm going to use f prime of x here. Okay. So because look at the theorem says, if f prime, okay, if the derivative is positive, then that means f is increasing. If the derivative is negative, then f is decreasing. So that's all I need to do. Hey, is the derivative positive or negative? So here we go. F prime of negative 100. Okay, I already have f prime. F prime is right here. So all I have to do is plug it in. And I don't need to know whether it's, I don't need an actual value. I just need to know it's positive or negative. Negative 100 times 2 is negative. So this is negative. F prime of 100 is positive. So this side is negative. This side is positive. Okay. Well, I know f prime of 1/2 is 0. So this is right there. Because how do I know that? I found it right there. So increasing from, oops, I need to do inclusive symbol. Inclusive 1/2 all the way to infinity. Yay! And then part C said, tell me the decreasing part as well. Okay, so B and C are related. Decreasing from negative infinity all the way to 1/2 inclusive. And that's it. Easy peasy. Let's do B. B, same question. So the first I'm going to need to find the extrema. So here we go. A, I need to do the derivative. I'm going to use the quotient rule. So here we go. F prime of x equals x to the third. So that's your u prime times x plus 8 plus x plus 8 prime times 1x to the third. So this is going to be 1/3 x to the negative 2/3 times x plus 8. The derivative of x plus 8 is really 1, so that doesn't really matter because 1 times x to the 1/3 is 1/3. Okay. All right, then from here, we would need to see if I can simplify this up a little bit. Okay. Okay, so can I make the negative 2/3 into positive? Yes, I can. Okay. This is already positive, so that stays on the top. Okay, the 3 goes on the bottom. So denominator of 3, so this is 3rd root of x squared. So that's what I really have. Plus over here, can I say that that's 3rd root of x over 1? I'm gonna find common denominator. So what I need to do is on this side, I would now have to multiply by 3 3rd root of x squared. 3 3rd root of x squared. Okay. Denominators are now the same. So now I can just put it over one common denominator. If that's the case, over here I still have x plus 8. Over here, I still have a plus 3, but 3rd root, okay, of those. Now, under the radical, I have x to the 3rd, and I have 3rd root, so that will cancel out. So now I just have an x. So from here, I would now have 4x plus 8 all over 3 times 3rd root of x squared. I need to find the critical point, so I need to set it equal to 0. So the first critical point is right away. Oops, why did I cross that out? Okay, the first critical point is right away. It's going to be the denominator can't be, right? So the denominator can't be 0. So the first critical point is 0. Then I need to take my numerator and set it equal to, you guessed it, 0. So that one will give me x equals to -2. So I have 2 critical points, okay? So I'm gonna now plug it into my calculator and find what? Minimum, maximum? Okay. So here we go. Let's do this thing. Okay. All right, tell me what to do. Why don't you give yourself a head start and then I'll catch up, okay? So put -2 on here, put 0 on here. Okay, then from here, I need to find minimum or maximum. So can we check? F of -2 is, we need to plug in -2 to the 1/3, okay, times -2 plus 8. So that's really 3rd root of -2 times 6, which is about -7.56, okay? And let's plug in 0. F of 0 is going to be 0. So one of it is negative. Okay, so currently this is 0. This is negative somewhere down here. And I still don't know which one is which. So let's do f of a -100. What if we have f of a -100? -100 to the 3rd is going to be negative, right? So that's on the outer piece. -100 plus 8, that's negative. So would you agree that's positive? Okay. So let's check 100. So f of 100 is positive 100 to the 3rd is positive, times 100 plus 8 is positive. So that's again positive, okay? So somewhere in the middle here. So it looks like it's starting from here, it goes to here, and then it ends up to here. So what's going on here? I'm gonna see, so does it curve back up anymore, or is it just continues to go like that? Okay, so that's really my question. And it seems like that's the case. So if that's the case, this right here, since there's not another curve go here, this 0 is neither minimum or maximum. So looks like my minimum is negative 7.56, or I can keep it as exact form as it was, negative third root of 2, so negative 6 third root of 2, because I can pull out the negative from the under the third root. Okay, so what happened is third root of negative 1 is the same thing as negative third root of 1, which is really negative 1. Okay, so you can pull out the negative in the front. So the minimum is decimal, or negative 6 times third root of 2 at x equals negative 2. So that's my minimum. So that is just part A. Part B, find increasing and decreasing. So I don't need to use 0, so keep that in mind, because 0 from our chart over here, it wasn't a minimum or maximum. So for part B, oops, I'm going to use f prime of x, so keep that in mind. Okay, so this is x equals negative 2. So I'm going to plug in f prime of negative 2 to see what it gave me. And f prime equation was found over here, right there. Okay, so here we go. Equals 4 times negative 2 plus 8 all over oh, I don't need to plug in negative 2. My bad, because that already gave me 0. So sorry, I need to think for a second. Sorry, that was already 0. So that's why this is 0. And how do I know that? Because, oops, how do I know that? Because this came from that, okay? The 2 came from that right there. So that's already 0, so don't need to worry about that. But need to plug in f prime of left-hand side of that, which is negative 100. So on the top, 4 times the negative 100 is negative. On the bottom, third root of a negative 100 square, well, negative 100 square is going to be positive, so that's always going to be positive. So this is going to be negative, so negative's right there, okay? And then, sorry, my lights in the classroom got turned off. And then we're going to do f prime of 100, which is, on the top is going to be 4 times 100 is 100, and on the bottom, 4 times 100 is 400. I meant positive. 4 times a positive 100 is positive, and anything square is going to be positive. That's always going to be positive. So this is positive. Okay. So increasing and decreasing. So let's check it out. Increasing, okay, from inclusive negative 2 all the way to infinity. Decreasing, this is letter C. Decreasing from negative infinity all the way to negative 2 inclusive.
Example number 5 from section 4.2. We'll start with the definition. Functions with f prime equal to 0 are constant. If f prime of x equals to 0, if f prime of x equals to 0 at each point on an interval I, at each point on an interval, let's call it I, then there is a constant, then there is let's call it C, constant C, for which f of x equals to C for all x in the domain of I. Okay. So in plain English, this is really saying this. Okay. Remember back in the days, remember the derivative of a constant constant function is 0. So this theorem or this definition is the converse of that. So the converse is also true. Now our second definition is functions with the same derivative differ only by a constant. So if f prime of x equals g prime of x, if f prime of x equals g prime of x at each point of an interval, let's call it I again, at each point of an interval I, then there is a constant c. Then there is a constant c such that f of x equals to g of x plus c for all x in the interval I. So an example of that would be f of x equals 2x to the 6 plus 800, and then g of x equals 2x to the 6 plus 1. So the derivative f prime of x and g prime of x are exactly the same, and the only difference is their constant c. Let's move on to our example 5 on the next page, for me anyway. Example 5 says, for each of the following, find the function with the given derivative whose graph passes through the point P. They gave us the derivative f prime of x equals 1 divided by 4x to the 3/4, and the point is 1, negative 2. Usually when I'm doing the derivative, I like to use power rule because it's slightly easier than quotient rule. So I'm going to rewrite this using a negative exponent, which is, this is going to give us 1/4 times x to the negative 3/4, just like that. It wants us to find the function, so that means it's f of x. So f of x equals, remember we're going backwards now, so when you go backwards, what you want to do with the power is you want to add 1. So 3/4, negative 3/4 plus 1, and remember, in the front, you have to think about something here. I want to keep that open. And then we always have to add c. This is the new key right here. We have to add c, okay? So with that said, you are given a point. X is going to be 1. Y is going to be negative 2. Let's try to see what's happening when you add negative 3/4 and 1. So f of x equals, there is a number in the front, the leading coefficient. So currently, if I add negative 3/4 plus 1, I will have a positive 1/4. Now, when you do the derivative, you have to glance at your derivative and you have to see, okay, what is the number in the front? Well, the number in the front is 1/4. So whatever function you have right here, will that give you 1/4? And right now the answer is yes, so we don't have to worry about the leading coefficient. It doesn't have to change. Now, but still you have to add c, drop that down. Well, you know what x is, you know what y is, we can just plug those in and then solve. So y is going to be negative 2 equals x is 1, 1 to the 1/4 plus c. We have to solve for what c is. Well, negative 2 equals 1 plus c minus 1 to both sides. C comes out to be negative 3. Now our final answer is f of x equals x to the 1/4 minus 3. And that is the regular function. So now you have to go and manually solve for your constant. Let's move on to the next example. Similarly, we want to go backwards. So let's find f of x is? Well, 2x, to go backwards, we're going to add an exponent. So x, currently the exponent is 1, so I want x to the 1 power plus 1, so that will give me 2. Now I have to think about the leading coefficient in the front of that. If I take the derivative, would that give me a 2? And the answer is yes, so I don't have to change anything with the leading coefficient. With the 1, the derivative of a constant, it's an x. Now the derivative, not the derivative, the antiderivative, the backwards way. So the antiderivative of cosine is to be sine. Okay, so if you go backwards, that's what you're getting. Now remember, we have to go and add c, whatever the constant is. So now that you have that, you want to plug in x equals to 0 and y equals to 3 and solve for what c is. So 3 equals 0 squared plus 0 minus sine of 0 plus c. Well, luckily, all of this turns into 0. So c comes out to be 3 right away. Then you're going to have your original function, f of x equals x squared plus x minus sine of x plus 3, and box that up. Okay. We have one last definition here. So what we were doing for example 5 is called antiderivative, going backwards. So the definition for that is a function f of x, and I'm going to use big capital F of x, is an antiderivative over f of x if big capital F prime of x equals f of x for all x in the domain of regular small x. For all x in the domain of f of x. The process of finding an antiderivative is called an antidifferentiation. So if you hear the word antidifferentiation, that's the same thing as antiderivative. The process of finding an antiderivative is antidifferentiation. If f of x has one antiderivative, if f of x, small f, has one antiderivative, let's call it big F of x. Okay. Then it has infinitely many. And each one differs by a constant. Okay, so what I mean by this is, if I give you an antiderivative, big F of x, is 1/3 x to the third, and I would like for you to find the regular function of that. So the regular function of that would be x squared. Well, remember, but this, to be fair, f of x antiderivative can have different form. They can all differ by a constant, and the constant can be anything you want to be. So technically I can have f of x, big F of x equals 1/3 x to the third plus negative 1000. Big F of x equals 1/3 x to the third plus negative 5. So whatever the constant is, you can have many big F of x, which is you can have as many antiderivative as you want. Example 6 from 4.2. This is our last example in section 4.2. So let's start with, I'm going to show you how to do example 6 two different ways. So with that said, I'm going to draw a line in the middle of my notes. Hopefully that will give me enough space to show you same exact question, just two different methods, okay? Okay, so we'll do both of them side by side so you can see the difference between the two. So method number 1 is, okay, so let's do the question. Example 6, part A. With what velocity will you hit the water if you step off a 10 meters diving platform? Remember, acceleration due to gravity is 9.8 meters per second. No, you may not round it to 10 meters per second square. I'm sorry, second square. So over here, we will have an assumption. We will assume your water position is going to be at 0, and we will assume diving board or diving platform is going to be at a position of 10 meters above the water. That makes sense. You're diving downward, so the diving board will be above you. Now, over here, you will assume the other way around. You will assume that the diving board will be at 0, and your water position will be at 10. Don't worry, both answers will come out to be the same. You just have to be mindful of a certain thing. Okay. Now, over here on the left side, you were given an acceleration of 9.8 meters per second square. That was stated in the question. But here's why the left side is important. Since you're diving downward, since you are diving, that means you're going down, okay? You have to manually understand that you have to change the given acceleration to a negative 9.8 meters per second square before you can use it. Okay. Now on the right side, because we're making the water higher than the diving board, we are setting the problem up to be a positive acceleration. Now you're going to end up with the same answer, except that when you are interpreting it, you just have to use the word diving or going downward or something similar to that effect. So we'll do both ways. Okay. On the right side, we are using everything as positive. So I'm going to do a star here. We want acceleration and velocity of the dive to be positive. All right. So let's start with the left. So we have velocity is going to be the antiderivative of acceleration. So negative 9.8 times t plus some constant. We have to find that constant. Now to find the constant, you have to be mindful. We will use the time at 0. You have to come up with a point that you know. So t equal to 0. That means velocity must also be 0 at t equals 0, because at the beginning of time you haven't done anything yet, you haven't gone anywhere, so your velocity has to be 0. Using that point, that will help us solve for c. So velocity 0 equals negative 9.8, t is 0 plus c. Well, this means c comes out to be 0, which is awesome because it makes it easy for us. So our first equation is velocity equals to negative 9.8 t. We'll highlight that for that piece. Now let's go over here to the right and do something similar. Again, we are now using the given acceleration as a positive measurement, so 9.8 meters square. So acceleration is going to be 9.8 meters per second square. Similarly, we want to find velocity, which is taking the antiderivative of that. So it's going to be 9.8 t plus c. And again, we are going to use at the beginning of time when t equals to 0, your velocity, it's also 0 because you haven't gone anywhere. That will allow us to solve for your constant c. As you can see, this is the same thing, so we get both answers the same except one is positive and one is negative. It will change slightly in a little bit. Now it says, at what velocity will you hit the water if you step off of 10 meters diving platform? What I'm going to do next is now I'm going to find the position. So s of t. So go backwards one more time. Okay. So s of t equals, now we have to go backwards. So we're going to add 1 in the exponent. So now t becomes a 2. Then, okay, I'm going to negative 9.8 is the number we currently have. Because this is a 2, we're going to divide it by 2 or multiply by a half. And don't forget to give us a c. And then we are going to simplify. This is negative 9.8 divided by 2, so that's a negative 4.9 t squared plus c. Yes, we do have to solve for c still. And similarly, we're going to start at the beginning of time when t equals to 0. When t equals to 0, remember, we have made it so that your diving board is 10 meters above the water. So what that means is when t equals to 0, your position is 10. So we have to plug it in and solve for c. So this is 10 equals negative 4.9 times 0 squared plus c. So c comes out to be 10. So your position is negative 4.9 t squared plus 10. We'll hold on to that and we'll go to the right and solve it similarly to the right side. So on the right side, again, we're going to go backwards one more time and do the same thing, do the same kind of math. And as you know already, we're going to get 4.9 t squared plus c. Now, similarly, we're going to use t equals to 0. At t equals to 0, we made it on this side that your diving board position is 0. So your s of t is 0. So when we plug it in, it's going to be 0 equals 4.9 t squared. Oops, t is 0, so plug in 0. So 0 squared plus c. So over here, c is still coming out to be 0. So over here, as you can see, your position is slightly different from the other side. Okay? All right. Now, so be mindful of that. Remember, the question wants us to find the velocity when you touch the water, the velocity on impact. That means when you hit the water. But to find the velocity when you hit the water or on impact, you need to know the time of when you hit the water. So from the position, we are going to solve for time. So we have positions on both sides. What we want to do is on the left side, s of t equals negative 4.9 t squared plus 10. Remember, your water on this left side is going to be at 0. So we're going to set it equal to 0. So 0 equals negative 4.9 t squared plus 10. Move 10 to both sides, so it's going to be a negative 10 equals negative 4.9 t squared. Divide both sides by negative 4.9. Move it up here because I don't have any more space. That's going to give us a positive 10 over a positive 4.9 equals t squared. I'm going to get rid of my decimals, so now I have 100 over 49 equals t squared. That means t is going to come out to plus or minus 10 over 7. Well, time can't be negative, so I can only take a positive 10 over 7. That is the time on impact. That's the time when you hit the water. I'm not really looking forward That's not my final destination. I'm looking for the velocity when I hit the water, but that is the time on impact. So what we want to do here is go back to velocity, which is right here. We plug in 10/7. So negative 9.8 times 10/7. This is going to give us a negative 98/7. Divide that, we will get a negative 14. So this is negative 14 meters per second. We will write a complete sentence in a little bit, but let's go to the right side to see what's happening if we use the right side equation. Now, similarly, we're going to find the time when you hit water, the time of impact. Well, water on the right side, remember we have decided that it is at positive 10. So we will take the right side. Water equals 10. So we are going to set equals to 10. We're going to solve for t again. As you can see, it's exactly the same, except on this side it's now positive. We know it's now going to be a positive 10/7 for the time of impact, the time that you hit the water. We will plug that back in the velocity because we are looking for velocity of impact. So v of 10/7 equals 9.8 times 10/7, and that will reduce us down to positive 14 meters per second. Now, on the right side, we have decided to keep everything positive. So on the left, we've decided to keep things normal, right? The water is below the diving board. So when you write your answer, it doesn't really matter. When you write your answer, you would use the word in diving down or falling or whatever it is that you want to use to indicate that this is a negative velocity. So the velocity when you hit water is negative 14 meters per second if you're using negative. Now you can also say the velocity from diving downward when you hit water is 14 meters per second. So notice how you're not using the negative sign with the word diving downward will take into consideration of the negative. So either one would be just fine. Now last part of 4.2. With what velocity will you hit the water if you dive off the platform with an upward velocity of 2 meters per second? Now this is slightly different. This is kind of like you're on the platform, you're jumping up a little bit and then going downward. So this is slightly different. So what's happening here is you are given a velocity 2 meters per second at t equals to 0. Okay, now but on the right side, we are slightly different here. On the right side, we made everything its opposite. So since we made downward velocity positive, then that means upward, that means upward velocity is now negative. Is negative 2 meters per second. Okay, so on the right side, v of t equals negative 9.8 from earlier, and again we still have to solve for our constant. At t equals to 0, we have a velocity of 2. So we plug it in. 2 equals negative 9.8 times 0 plus c. As you can see, this c comes out to be 2. So our velocity is negative 9.8 t plus 2. We'll hold on to that. We'll go to the right and do the same exact thing. Earlier we had a positive velocity of 9.8 t. We want to find c. At t equals to 0, over here our velocity is now a -2. So -2 equals 9.8 times t plus, sorry, we need to plug in 0 for t, times 0 plus c. So c comes out to be a -2. So on the right side, velocity is 9.8 t minus 2. We'll do the same thing. Okay, now let's go and move on to position. S of t equals, and earlier, from our math earlier, I'm going to go straight to -4.9 t squared plus now 2t, we're going backwards, plus c. We're looking for the constant of our position. Now at time equals to 0, on this side, I think we made our diving board at 10. So we are going to have position at 10. So 10 equals -4.9 times 0 squared plus 2 times 0 plus c. C comes out to be 10. So the position equation is -4.9 t squared plus 2t plus 10. We will hold on to this position. We would definitely need to solve for the time in a little bit, but go on the right side and do the same thing. Position is going to be 4.9 t squared minus 2t plus some constant. Remember, over here, we made the diving board at 0. So, at time equals to 0, our position of the diving board is 0. So, 0 equals 4.9 times 0 squared minus 2 times 0 plus c. This tells me everything is 0. So, our position on this right side is 4.9 t squared minus 2t plus 0, but why would you want to write that? Okay, so we have two position equations depending on what we assume at the beginning. So now we need to find the time of impact. On the left side, I'm going to use our, doesn't look like factoring, it's that friendly, so I'm going to use the quadratic formula. So -b plus or minus square root b squared minus 4ac all over 2a. So -2 plus or minus square root b squared, so that's going to be 2 squared minus 4 times a, which is -4.9, times c, which is 10, all over 2 times -4.9. Now let's try to simplify this all out. This is -2 plus or minus 10 rad 2 all over -9.8. So now plug it in your calculator. One of it's going to give you a negative time, which we can't keep, and then one of it's going to come out to be 1.65, which we will keep. So for this side, now velocity on impact. Let's go back to velocity of impact. So here, V of 1.65 is, plug it all in, you're going to get 14.4 meters per second. That's our velocity on impact. On the right side, we would do something similar, except on the right side, remember our diving board is 10. So, oh, it was the diving board 10? Let me go back and look. No, we said the diving board was 0 and water was 10. So water is where we're in, where we touch water, which is 10 equals 4.9 t squared minus 2t. And again, similarly, we will try to solve for t, which is the time of impact. So move the 10 over. So 4.9 t squared minus 2t minus 10. Again, use your quadratic formula. So t equals -b, which is 2 plus or minus square root b squared, which is going to be -2 quantity squared. So 4 minus 2 times a, which is 4.9, times c, which is -10, all over 2 times 4.9. All the numbers are exactly the same. For this one, I'm going to simplify that down to 1 plus 5 rad 2 all over 4.9. After I simplify, as you can see, I got rid of the negative because it's not plus or minus anymore. I'm only keeping the positive time. So once I plug it into our velocity of impact, v of 1 plus 5 rad 2 all over 4.9, this is going to give us a positive 14.14 meters per second. Can you do me a favor? I forgot. Can you do me a favor and go and put a negative right here? I forgot the negative sign. Because when you plug in negative 9.8 times 1.65, it's going to turn out to be a negative answer. So, similarly to either method, one will give you a negative sign right away, indicating that you're going to go downward, and one is going to give you a positive answer because we're making all of it positive. So when you write your final answer, you just have to use the correct wording. Okay. On the left side, you would say the velocity on impact would be negative 14.14 meters per second. That's the left side. On the right side, you can say the velocity on impact when diving downward is 14.14 meters per second. So the word diving downward will take care of your negative. So go ahead and write your complete sentence, and that's a wrap.